Shall we start?
Yes, it's 12 o'clock we start. Yes, thank you.
Welcome back, everybody. We're going to be doing a Physical Sciences Grade 11. I'm Mosala Leguru. You can get me on Twitter. My handle there is @MosalaDL. And then on Instagram, you can get me on this handle, post_silicon. Right, we're going to be doing the homework together, the feedback from the homework. Right, the homework was saying, consider a circuit diagram below. The internal resistance of the battery and any resistance in the wires can be ignored. 1, calculate the value of resistor R if the total resistance of the circuit is 4,8 ohms. And then the next question was, calculate the reading on the voltmeter if the current through the 4R resistor is 1.8 amperes. Question 3, calculate the energy converted in the resistor 4R in 2 minutes. And then there's this leading question, the resistor 4R, the 4R resistor is replaced with the ammeter. How will the reading on the voltmeter be influenced? Right, only increase, decrease, or stay the same? Explain your answer for question 4. So let's see the responses. All right, the first one was to calculate the value of resistor R if the total resistance of the circuit is 4,8 ohms. Right, the first thing we will be looking at this parallel, this resistor, 4R resistor, and these 3 resistors are in parallel with each other. This one, the 4R is in parallel with this one. This 1, 2, 3 resistors. Now, what we do, we calculate the resistance in parallel. That is, we calculate effective resistance in parallel connection because this and these 3 are in parallel. So we use the formula 1 over Rp equals to 1 over R1 plus 1 over R2. But what is that we do is that we just take we can just go back. We take this to be in series. This R and 2R and 3R, they are in series with each other. So being in series with each other, it means their total resistance in the series part. It will be R plus 2R plus 3R, which is 6R. So this loop here of 6R is in parallel with the with this resistor of 4R. So let's see. So this will be, where is R1, will be writing these 3 together, which gives you 6R. And then plus, this one is 4R, 1 over 4R. So this will be, 6 goes how many times into 12? It will go 2 times. And then that will be a 2. And then times 1, which is 2. And then 4 goes how many times into 12? It goes 3 times. And then that will be, so 4R goes how many times into 12R? It will be 3 times. And then 3 times 1, it will be a 3. So 2 plus 3 is 5 over 12R. Therefore, it means R parallel will be equals to what? Will be equals to 12R over 5. Remember this part here, 5 over 12R is equals to 1 over PR. So it means we have to invert to get a RP, that is R parallel. Here is whatever you're getting here, 5 over 12R, it is the reciprocal. So for you to be having the real value, you have to be going for the reciprocal of this, which is 12R over 5. Then 12R over 5 will be 2,4R, right? So that is the resistance, the total resistance. But this resistance is equals to what? We've been told that this is equals to 4,8. The total resistance in the circuit is 4,8. So it means this 2,4R equals to 4,8. So if you divide both sides by 2,4, you are going to be getting 2. So R is 2. The value of R is 2, right? Now we have already calculated the value of R to be 2 ohms. We know that we have done that in number 1. Now calculate the reading on the voltmeter if the current through 4R resistor is 1.8. Calculate the reading on the voltmeter if the current through the 4R resistor is 1,8 ampere. So what we know is that V, that is the voltage across the 4R resistor, will be equals to IR, right? So we have been told that, so this is how we calculate it, but we have been told that the current through this particular resistor, the 4R resistor, is 1.8. So we substitute 1.8 for I, which is the current. But we know what is the value of R. R, we have calculated its value to be 2. So it's 4 times R. So this will give you the voltage across this will be equals to what? It will be 14,4 volt, right? So now, but this is not what we are asked to calculate. We're just asked to calculate the reading on the voltmeter. Now, what is that we know about resistance? So the voltage. We know that the resistors that are in parallel will have the same voltage. So what does that mean? It simply means these resistors will have the same, because they are in parallel. The 3R, the 2R, and the R are in parallel with the 4R. So they will have the same resistance as the 4R. So what is that we know also? We know that the 4R will have the voltage in 4R resistor will be 14,4. We have just calculated it. But the question wants the reading on this voltmeter. So how do we get that reading? We know that I, current, equals to what? Equals to voltage over resistance. Now, why are we doing this? We want to know what is the current that is flowing in the R resistor, 2R resistor, and 3R resistor. Remember, with current, the parallel resistors are current dividers. So current has been shared between this 4R resistor and these 3 resistors, right? So we want to know how much of the current will be coming to this side. Remember, the current in series resistors will be the same. So once we know how much has been shared between these three and this one. So because these three will have the same because they are in series with each other. So we say 6R. Why are we saying 6R? 6R is this 3R plus 2R plus R will give you 6R. So now this is the, we are saying current there will be equals to V over R. So now we know V because voltage is the same in parallel resistors. So is voltage will be 14,4 divided by 12. Where do we get 12 from? It's 6R. So it means it's 6R. The value of R we have said is 2 ohms. So it is 6 times 2, which is 12. So the current that is flowing here, it will be 1.2 ampere. Right, now we know that voltage, we want to know the voltage, the reading on this particular voltmeter. So V equals to IR. So what does that mean? It simply means we have to multiply the current by the resistance. Now, the current we have said is 1.2, and this is 2R. So it's 2 times R. R is 2. So this is 4 times 1.2, which is 4,8. Right. Now, that was the homework. I'm not sure if there's any question, any clarity from your side. Okay, in the absence of that, let's continue. We want to continue with electric circuits, but in this instance, we'll be looking at the energy and power on electric circuits. Energy and power on electric circuits. So let's just go through it. What is that we are expected to know at the end of this lesson? At the end of this lesson, you should be able to define what power is. You should be able to define what power is, and then solve problem using the equation power is equals to work done over time. And you must remember that work done equals to VQ, or V equals to W over Q. And therefore, by substituting V equals to IR in the equation, we are going to get V equals to what? VIT, right? So W equals to VIT, meaning that where you see, if you substitute V with IR, this is what we are going to end up having. And then if you continue, let's say if you, where you see, when you say W equals to VQ, and then if you substitute IR for V, this is what we are going to get. We are going to get work done or energy transferred equals to I squared multiplied by R delta T squared. Delta T, sorry. So what does that mean? It simply means here you're having VI delta T. So where you see V, you are substituting IR. So you have not, we are going to have I squared because I was there, and the new R which was coming from there, and then delta T. And then once you go back here, and then you substitute what? You substitute where you are seeing I, you substitute the I. So it simply means I here will be equals to what? will be equals to V over R. Then this will be V times V, which will be V squared over R delta T, right? So that one is just my mathematical manipulation. You can always do that. Try to substitute here what they've done, instead of having W equals to VIT. So instead of I here, they've substituted I, which I equals to V squared over R. Sorry, V over R. Then they got V squared over R. And then here you're having W equals to VI delta T. So instead of V, you substituted IR. So it will be I squared R multiplied by delta T. Right, so deduce by substituting into this equation, the following equation will be obtained. So we know that for P, power is equals to VI. So if power equals to VI, then if you are substituting where you see, for argument's sake, where you see V, you substitute IR. So instead of having V here, you will have IR. So it will be I squared R. And you do the same here. Where you are having I, you are substituting V over R. So it will be V squared over R. And solve the problem using all of these equations that are related to power. Right, you have to solve problems involving the concepts of power, electrical energy, and then also you have to deduce that a kilowatt hour refers to the use of 1 kilowatt of electricity for an hour. And you must know that 1 kilowatt is the amount of electrical energy, and it's also known as unit of electricity. Normally, when you buy electricity, when you have bought about, let's say 100 units, it means you have bought 100 kilowatt hour. And then you have to calculate the cost of electricity usage given the power specification of appliance, and then the duration and the cost of unit of electricity. Right, let's continue. What is power? Power is the rate at which work is done or the rate at which energy is transferred. It is the rate at which work is done or the rate at which energy is transferred. And then you must remember that W equals to VQ. And then we know that Q equals to IT, I delta T. Therefore, W will be equals to, where you are seeing Q, you will be substituting I delta T. So it means W will be equals to V I delta T. Right, by substituting V equals to IR in the equation, this is what we are going to be into this equation, W equals to V I delta T. We are going to obtain this equation. Now, in this one, where you are seeing V, we are substituting IR. So is IR, so it will be I squared R delta T. Because I and delta T were there, then you are bringing IR. So it means it will be I squared and then R delta T. Right, if you substitute I equals to V over R in this equation here, this is what we are going to, in this particular equation, if you substitute I equals to V over R in this equation, you will be obtaining this part here. That is where you substitute I with V over R. You are going to be getting V times V, which is V squared over R. Delta T is there, delta T, and then I is what we have substituted. So you must know where this equation comes from. But more importantly, these equations will be in your formula sheet. So there's no need to crack your skull, but this was just to help you to understand where we get these equations from, where are they coming from, so that you can understand where are we getting them from. Yeah. So this is what you need to understand. Just understand, and you should be able to use them with the given information. Now, kilowatt hour, kWh, refers to the use of 1 kilowatt of electricity for an hour. So kilowatt is the amount of electrical energy. It is also what? The unit of electricity. Now, let's try to deal with this particular problem here. The circuit below consists of a 6 ohm and a 15 ohm resistor connected in series. So now these two, the 6 ohm and the 15 ohm, they are in parallel, but they are also in series with resistor R, with unknown resistors. With unknown resistance, resistor R with unknown resistance. Right, now, an ammeter, a high resistance voltmeter, a closed switch and a battery are connected as shown. An ammeter, a high resistance voltmeter, a switch which is closed, and a battery which is here are connected as shown. Right. The first information that we have there is that the total power dissipated in parallel part of the circuit is 50 watts. 50 watts. Right. Now, define the term power. And then the other question is calculate the effective resistance of parallel combination. 10.13, calculate the potential difference across the resistors in parallel. 10.14, calculate the current through resistor R. Right, define the term power. What is power? Power is the rate at which work done or the rate at which energy is transferred. So power will be the rate at which work is done or the rate at which energy is transferred. And then calculate the resistance of parallel combination. How do you calculate the resistance of parallel combination? Right, we use the equation 1 over Rp equals to 1 over R1 plus 1 over R2. Now, we know that this will be what? Equals to what? R1 is 6 ohm, so we substitute that 6 ohm. R2 is 15 ohm, so we substitute the 15, and then the resistance there is 30. Sorry, the LCD is 30, lowest common denominator is 30 of where 15 and 6 goes without a remainder. So it's 30, the lowest number that 6 and 15 can go without any remainder is 30. So now, first thing is that 6 goes how many times into 30? It goes 7 times. Sorry, let me just see. 6 goes how many times into 30? It will go 5 times, sorry. So it will be going 5 times into 30, and then 15 goes how many times into 30? It will go twice, and then 2 times 1 will be 2. So this should be 2 plus 5, né? And then equals to 7 over 30, because 6 goes 5 times into 30, and 15 goes twice into 30. So it's 5 plus 2. So this should be 7 over 30, 7 over 30. And therefore, R parallel should then be 30 over 7. Should be 30 over 7. Sorry for that. That should then be equals to, sorry, let me just reach out for my calculator. That should be 30 divided by 7, which is 2.29. So this is not, this number here is not a 7, it's a 5. And this one is not a 7, it's not a 9, it's a 7. So the answer there that you are seeing is correct. The answer that you are seeing there is correct, of saying your R parallel will be 4.29. So your answer is correct, but here you are having 5 plus 2, which is 7 over 30. And then here is 30 divided by 7, not divided by 9. Right. Calculate the total power dissipated in parallel part of the circuit. So no, the total power dissipated in the parallel part of the circuit is 50 watts. Now, calculate the potential difference across the resistors in parallel. And then calculate the current through the resistor R. So what is the current through the resistor R? Now, the first thing is to calculate the potential difference across the resistors in parallel. So we know the power equals to V squared, because we are looking for the potential difference, and then over R, we know the resistance. We have calculated the effective resistance across the parallel combination. Right, now we also know that this will be 50, which is the power dissipated is 50 watts. V squared is what we do not know. And then we know that the resistance, effective resistance across parallel combination is 4.29. 4.29. So this will be 4.29 times 50, which is 4.29 multiplied by 50. It should give you 2145 somewhere there, but because I did not round it off, I just multiply it as it was in the calculator. So you should be arriving at around this number 2142.86, which should be, therefore your voltage would then be what? 14.65. So that should be your answer, 14.65 volts. Right. The next question was to calculate the current through resistor R. How do you calculate the current through resistor R? Now, calculating the current through resistor R will then be, we know that E equals to I squared multiplied by R. So All right, we know that this will be the power dissipated in the circuit. It will be 50. So it's going to be 50 multiplied by what? Multiplied by I squared. And then what is R? R, what we are looking for, sorry. I'm struggling to view. Okay, and then we are looking for the current first thing. So what is that we know would be that the current through this part here will be equals to 3,41. That is the current through this particular part here. Now, we want to know the current that is going through R. So, it means the current that is going through R will be the same. Remember that if the current that is going through this parallel combination, that is parallel resistors, is 3,41. It means it will be the same because R is in series with these ones that are in parallel. So that will be the current that will be going through R. So remember, what is important for you to know is that this 3,41, when it comes to this point, it will be divided between the 6 ohm and the 15 ohm. But what we know is that the current that is coming through to this, all of it, before it's split between the two, it is 3,41, right? Because it is the current. Remember, this power is the power that is dissipated in the parallel part of the circuit. So if this power is being dissipated, it means, all that it means this current is being shared between these two. So its value is 3,41. So we substitute, we know that P equals to I squared multiplied by R. So P is 50, I is not known. R, we have said that these two, their effective resistance will be 4,29. So we substitute 4,29 for them. Then we solve for I squared will be 11,655 and I will be equals to 3,41 ampere. But we know this resistor R and these parallel resistors, they are in series with each other. So it means their currents will be the same. So remember, in this instance, this I, it is the current that is being shared between the 6 ohm and the 15 ohm resistor. Right, now, the switch in the circuit is now open. How will the reading on the voltmeter be influenced? Choose from increase, decrease, or remain the same. So now the voltmeter reading will decrease. Why? Because effective resistance in the circuit will increase. However, resistance will be the same around R. Remember, if you open the switch, you will no longer have a parallel combination here. You'll just have this R resistor R and 6 ohm resistor being in series. So the effective resistance in the circuit will increase. But resistance of R will stay the same. Right. Thus the current and voltage will decrease because R around this will be the same. So if voltage and current will have to decrease because V equals to IR. So R is the same. So if I decrease, it means V also decrease. Right, now let's continue and look at some of these questions that are applicable, particularly for today's lesson. Today's lesson, we want to know power system, energy and power in electric circuits. So in here, we want to know what the effect of the geyser. A geyser labeled 2000 watt, it is used for an average of 5 hours per day. The cost of electricity is 80 cents per kilowatt hour. So remember, we have said the unit for electricity is kilowatt hour. When you have bought, let's say, 100 units of electricity, you have bought 100 kilowatt hour. So now, calculate the energy used by the geyser for 5 hours per day. Calculate the energy used by the geyser for 5 hours a day. Right. The other thing is calculate the cost of electricity to operate the geyser for a month with 30 days. Now, power equals to what? Energy or work done per unit time. Right. So power here is 2000 watt, and energy used is what we do not know, the work done. And then what is the time? The time is 5 hours per day. But normally we are measuring time in seconds. So there are 60 minutes in an hour and 60 seconds in a minute. So time is 5 hours a day. So it's 5 hours, but there are 60 minutes in an hour and 60 seconds in a minute. So now that is why we are multiplied by 60 twice. Right, therefore, work energy that will be used by the geyser will be 3,6 times 10 to the power 7 joules. So it means it's 3, 6, and 6 zeros in the other version. Right, 2.2, calculate the cost of electricity to operate the geyser for a month with 30 days, a month with 30 days. Now, the cost will be equal to 80 multiplied by what? Multiplied by 2. Why are we saying 2? It is 2 kilowatts. Kilo means 1,000, so it's 2 kilowatts. That is the unit for electricity. Kilowatt and hour here. And then it is 2 kilowatts, 2,000 watts, 2 kilowatts. And then multiply by how many hours? 5. In how many days? 30 days. So the price is 80 cents multiplied by unit kilowatt hour. So kilo means 1,000. So it's multiplied by 2,000 watts, which is kilowatts. Hour is 5 hours multiplied by 5. In how many days? In a month with how many days? 30. Right, so the cost will then be 80 multiplied by 2 multiplied by 5 multiplied by 30. It should give you 24,000 cents. And then how many cents are there in a rand? It will be 100. Therefore, if you want the cost in rands, we'll have to divide this by 100 because there are 100 cents in a rand. So in rands, it will be 240 rands. Right, let's continue. Next that you need to do, it is your homework. Please try this one. Right, it reads as follows. A circuit consists of 4 cells connected in series, each with EMF of 3 volts. The battery is then connected to 2 external resistors of 5 ohm and 2 ohm connected in parallel. 2 resistors are connected in series. 2 resistors are connected in series with a third resistor of 2 ohm. So where it is black there, it should read 2 resistors are connected in series with a third resistor of 2 ohm. Right, you can have a snapshot of this one as we'll be wrapping up. All right, I hope you have managed to get it. In case you could not get it, you can always go to YouTube and then get the whole presentation. Now remember the concepts and definition of power discussed in this particular session, sorry. And then you must be able to do calculation in electric circuit as well as power energy in electric circuit. Right, continue to use past DBE question papers. Remember to practice and practice and practice. And then where you need help, please seek help. Right, let's quickly recap on what we have done today. Right, remember after going through the homework that we had on the previous lesson, we said we should be able to define power to solve problem using the equation power equals to work over time or energy transferred over time. And then we have said work done equals to the product of voltage times the quantity of charge. And therefore, by substituting IR in the equation, W equals to V I delta T, this equation of W equals to I squared R delta T, and this one of W equals to V squared over R multiplied by T will be obtained. These equations will normally be given in a formula sheet. If we can go to a DBE website and download the previous grade 11 question papers, paper 1, you should be getting the formula sheet at the back of the question paper. So these equations will be there. In case you forget them, you don't have to end up losing marks because you are mixing them up. So they will be given at the back of the question paper. So you can print out strictly that paper or have a snapshot of that page with the equations, and then you can always refer or write them down and always refer to them. And then deduce by substituting P equals to W over delta T into the above equation. And then you will also be getting the following equation: power equals to VI, or power equals to I squared R, or power equals to V squared over R. So now this equation, like I'm saying, they will be given in your formula sheet. So we have said you should be able to use this equation to solve problems. And then you should also be able to know how to go about solving circuit problems involving concept of power and electrical energy. And then deduce that a kilowatt hour, that is kWh, refer to the use of kilowatt of electricity for an hour. Right, know that kilowatt is the amount of electrical energy, and it is also known as unit of electricity. And then you must be, we have just calculated the cost of electricity usage given the specification of the appliance use, the duration, and the cost of 1 kilowatt hour. Right, so basically that's what we have done today. And then let's carry on, and as I'm closing, I've also given you this homework. Please try it. Tomorrow we'll go through it together, but it will be best if you go and do your best to try and get the solutions. And then I've told you that to remember definition: what is power, what is a kilowatt hour, and then how to use various equations in calculations. So I hope that we have gained something from this particular lesson. Right, let's meet tomorrow. We'll do the homework and then continue with electromagnetism. Right, you can get me on, my email is mosala.liburu@gmail.com. And then on Twitter, you can get me at mosaladl. On Instagram is post_silicon. Thank you. Until then, bye-bye.